Okay, if it's alright with you, we're going to do this a little differently today because I'm going to be doing a decent amount with the calculator. I wanted to just go through this. I'm going to, rather than doing some writing on the paper, I'm going to graph using just a program, and you can fill in your graph here while I'm doing that. But we're going to be working on linear regression and statistics too. So the first thing I want to make sure you do is we're going to turn the diagnostics on in our calculator. So how do you do that? We're going to go ahead, and I'd like everybody to do this with me. Go to second and then the number 0, and we're going to scroll down till we see diagnostic on. Again, this is going to take us a minute, probably you less time than me because my thing works slowly. But I'm scrolling, it's alphabetical order. Wait till this guy says diagnostic on. And there it is. Click enter and go for it. Alright, so that's the first step. So now it says enter the following data into the graphing calculator. So we're going to be doing this step by step. So the first thing I'm going to do is I'm going to go to stat, edit, and we're going to put this data in there. So I did it already, but I'll clear out. If you have anything in there, just clear, go up, hit clear, and enter that stuff. Alright, so in the L1 we have -2, 0, 2, 4, 6. And we're going to go over, and this one's going to be -1, 0, 1, 2, 3. Alright, so we get that data in. Now it says plot the points using the following graph. We know we have these ordered pairs. So we're going to leave the calculator alone for a second, and we're going to go ahead and we're going to plot these points on a graph. So I've got my graph right here. It looks just like the one you've got on the paper, but let's go ahead and graph a few of these. So the first one is -2, -1, and that would be -2, -1 is right here. And the next one is 0, 0. That means I don't go left or right at all, just right there at 0, 0. And the next one I'm going to do is 1, 2. So we go right 1 and up 2. Or I'm sorry, 2, 1. Got that. So this is 2, 1, which means I go to the right 2 and up 1. 4, 2 means I go right 1, 2, 3, 4 and up 1, 2. Again, double check to make sure these axes are counting by 1. And the last one is 6, 3. So 6 and then 1, 2, 3. And you can see these do look like they're falling on a straight line. These do look like they have a linear pattern. This is not always going to be the case, but just getting used to this process at first. That is what our plots should look like right here, so you can go ahead and fill those in. Now it says using the linreg a plus bx function, write the equation of the line and list the values for r. So here's what we're going to do. We're going to go back to our calculator. We're going to click stat. We're going to go over to calc. And you see linear regression ax plus b here. You can use that one. That's like your y equals mx plus b for those of you who are used to your traditional lines. But the Math Excel homework really likes this a plus bx form for some reason, so we're going to use that. And we are going to make sure we have L1 for our x, L2 for our y. We don't need a frequency. We're not going to store the regression. And there it is. So how do I go from this to plugging that in? Well, you can see that they give us values for a and b, and we're going to put those in there. So my equation is going to be y equals, where that a is, I have it right here. You can kind of see on the sky of the screen. A is 0 plus, what did we get for b? 0.5, and then x. So I think we can simplify this. Do we really need that 0 there? No. If it was a whole number, we'd leave it, but our equation is just going to be y is equal to 0.5x. If you want to have the 0 plus 0.5x, that's okay. I just think that we can kind of clear that out and make that look a lot nicer. And that would be our equation. Now for our value of r, you see what that is? That is actually 1. And we're not going to go into this too much, but if you find a perfectly straight line, that r value is going to be a number really close to 1 or -1, because that's telling us we have correlation, which we'll get into in statistics. But for the sake of what we have here, we're just going to list 1 for r. Alright, so now a little bit more applicable of an example. It says the following data corresponds to the year a cost of a movie ticket. That doesn't make any sense. What should that say? For the year and the cost of a movie ticket. That's much better. Sorry, editing in the video is never a good idea, but we're hanging in there. So anyway, the first thing we're going to do is enter this data in the graphing calculator. We've done this before. Hit Stat, Edit, go over. We're going to clear this stuff out, and we're going to put the data that we have in. So the first one, year is always X values. So whenever you're dealing with time, that's always going to be X values. So we're going to put that in. All right, and then we're going to put the price of a movie ticket. Oops. All right, just make sure you got your L1 and L2. Do a double check real quick. And then the next thing it does is ask us to plot those points. So let's go ahead and do that. So there's my plots right here, and I'm going to move this down a little bit so I can see both these at the same time. All right, so the first one is 1992 and $4.15. So where is 1992? Well, it's somewhere around here between 1800 and the year 2000. So let's say 1992 is here, and then $4.15. This is 2, this is 4, and 15 is going to be somewhere up here. All right, the next point is going to be 1997 and $4.59. So 1997 is going to be even closer to 2000, and $4.59 is going to be just above that. Again, are these perfect? No, but we're just trying to get general estimates, okay? We're just estimating, we're graphing these points as best we can. 2002 and $5.80, so 2002 is going to be just to the right of the year 2000, so like right here. And we said $5.80, so halfway between 4 and 6. You can see I'm using this axis here. Here's 4 and 6, so we're going to be just above halfway up that and pretty close to that 2000. So I'm going to put that kind of right here. And 2008 and $7.18. So 2008's over a little bit more. Here's 6, 7, and 18 cents. And 2016, $8.65. So 2016 is going to be somewhere here, $8.65. That's going to be up here. So you can kind of see this might not be a linear pattern. You can see that this is growing pretty rapidly, but again, we're going to do our best to calculate a linear regression with those. So when you graph these points in this plot, they're not going to be perfect, but just do the best you can. And now let's go ahead and run our regression. So we're going to go to Stat, we're going to calc number 8. Come on, there it is. A plus bx. Yes, yes, cool, great. Calculate. All right, so our equation is y is equal to, it's ax plus b. So I'm going to kind of slide this over so I can take a look here. It's going to be, we're going to need to round this, of course, but it's going to be y is equal to negative 388.61 plus b is 0.197 x. Let's just do 0.197x. And what do we get for our r? Our r value is 0.99. That means, again, we have some serious correlation going on here. So again, what we're doing in this lab is we're just getting used to plotting points, getting data in the calculator, and then cranking these regression equations out.